Reactions in aqueous solutions. Again, this is another topic that is not entirely new, which is why I certainly do not mind doing it as video lessons. So basically, when you have two aqueous solutions mixed together, there are two possible outcomes. Number one, you have no reaction, so there's no dissolving, all the ions remain in solution, nothing is happening, or you get a reaction. One reacts with another, and you see a chemical change. Don't forget that there are things that you have to look for to see if a reaction has occurred. First sign of a reaction, of course, you have your precipitate form, and this is your typical example. Lead nitrate, potassium iodide, you have two clear colorless solutions, and when you join them together, you get that nice, infamous yellow precipitate form. Another sign of a reaction, of course, is gas bubbles being formed, and this is because ions are removed from a solution in the form of a gas. And the third sign of a reaction is actually that you get water formed. So you get hydrogen and hydroxide ions removed from the solution, and they form water, and this is the form, getting steam created. Now, I know this kind of looks confusing, okay, but all this is a double displacement reaction. So if you look at this compound and this compound, the Y and the W switch places. So the W goes with the Z, and the Y goes with the X. Okay, so the W and the Y are the cations, and they switch places, and the X and the Z are anions. So that is a double displacement reaction. Now, double displacement reactions, some of them will form precipitates. So this is where we have used the solubility guidelines to find out if a precipitate forms or not. And remember, when you look it up on the solubility table, it will either say S for soluble or I for insoluble. So if one of the products is insoluble, that's meaning that a solid is being formed and it is a precipitate. If both products are soluble, then there is no reaction. And we have done this before. So for example, the classic example, lead nitrate with potassium iodide will form lead iodide. If you look that up on the solubility table, it is insoluble, therefore forms a solid, and the potassium nitrate are both soluble. If you look at this example, potassium nitrate plus sodium chloride, when you look up, you're going to actually have potassium chloride plus sodium nitrate. And when you look up both, they are both soluble. So instead of writing that out, we write no reaction. You can have double displacement reactions that form gas bubbles. So you can have hydrogen gas, you can have dihydrogen sulfide. That's that nasty smelling gas that we use that students love to put around the school in stink bombs. You have sulfur dioxide, carbon dioxide, and ammonia. Those are typical gases. Some double displacement, so an example of one producing hydrogen gas, okay, you have lithium hydride and water, and the lithium and the hydrogen, remember this is hydrogen and hydroxide, so the lithium ion will change places with the hydrogen, and that will give you lithium hydroxide, and you are left with and what you're left with is this hydrogen coming here, and you have the two hydrogen, which is your hydrogen gas. You can have hydrogen sulfide gas being produced, and basically you can have potassium sulfide reacting with hydrochloric acid. The potassium and the hydrogen ions switch places, so the potassium goes with the chlorine to give you potassium chloride, and then you have the hydrogen going with the sulfur to give you hydrogen sulfide gas. Some reactions actually produce compounds that are unstable, and we did talk about this in the last unit. So if you don't remember, this is a quick review, you will have something, for example, with this reaction, you will have the sodium chloride being formed, and you will have hydrogen sulfate, but it's H2SO3. What happens is that basically breaks down, and you get SO2 gas plus water. So this highly unstable product doesn't occur, doesn't happen. It's sort of an intermediate step. So the overall reaction is your two reactants and then your products, which are right here. So your overall is this whole equation. Carbon dioxide gas, same thing. We've talked about this in the last unit again. You will have your two reactants, okay? You will have that intermediate product, but then overall you have sodium carbonate and hydrochloric acid producing your sodium chloride, your carbon dioxide gas, and your water. And then finally, the ammonia gas, same thing. You get that intermediate step, and overall, that's your products. All of this is review. I just want to point that out. So it is something that you should remember from a previous unit. Now, we also talked about this briefly, neutralization reactions, and the reason they are neutralization reactions is because you have an acid, you have a base, and then what you end up producing is salt and water. So that's a neutralization reaction. And then finally, you can have double displacement reactions that form water. You have your metal oxide, okay? You have your acid to produce water, and you can have your non-metal oxide and a base to produce water. So this is just a real quick recap of aqueous solutions and reactions that can happen with them.